Okay, two charges, positive Q and negative Q, are situated at a certain distance. At a point exactly midway between them, okay, the electric field is 0, potential is not 0, or whatever, yeah? So this question is about talking about electric field and electric potential. Okay, let us draw out the situation first. We always draw the situation first, to help us understand the problem. So okay, I can write like this. So this is a positive Q and this is a negative Q. Okay, positive Q, negative Q. Okay, let me make it smaller. All right. Okay, wait, hold on a second. Okay, so positive Q, negative Q. So at the point midway, he asking about midway. Okay, exactly midway between them. That means which it is at here, midway. Okay. So what is the electric field at the midway? At the center between positive Q and negative Q. And about what is the electric potential? So you learned already about electric field and also potential. Okay, field is kq over r square. Potential is kq over r. Okay. One thing to know that field is a vector. It has vector, has direction, but potential is a scalar quantity. Scalar quantity. So for field, a vector, you need to add it using a vector method. Okay, but for potential, you just total up, no direction. No direction, no need draw vector. Okay, so okay, let me show you. All right, let me write down. The field equation is kq over r square, whereas potential is kq over r. Field is a vector. Okay. Whereas potential is a scalar quantity, has no direction at all. So we also learned about field has direction like this. I see field has direction. Positive charge, field is going out. If negative charge, field is going in. Okay. So this one, field, but potential doesn't have all this direction. Okay. So let's talk about field first. Electric field. So I want to know the field at this point, at the center. I put this point as point, let's say I put this point as point O lah, okay, the center O. So, okay, let's talk about field. First of all, let's talk about field. Okay, field is for positive charge. Positive charge of field is going away from positive charge, isn't it? Away from positive charge. So that's the field. So at this point O, the field is actually going to the, okay, maybe I put this as charge 1, this one as charge 2. Okay, for electric field for charge 1 is going out lah, okay, going out of the charge. For electric field for charge 2, because it's negative charge is going in towards the charge lah. Okay, towards the charge. So this is electric field for 2. Okay, so at point O, electric field, let's draw the electric field from charge 1. So it's going away from the positive charge. That means electric field 1 is going to the right, going away from the positive charge. Understand? Positive charge. Whereas the negative charge, electric field E2 is going towards the negative charge. So I can draw it. That means I can draw E2 is over here. This is E2. E2 is going towards the negative charge. E1 is going away from positive charge. Yeah, E1 is going away from positive charge. E2 is going towards the negative charge. So you can see the total electric field at point O is not 0 because E1 and E2 at the same direction. So I can say that, okay, So for E total, the total electric field at point O is not 0. It is equal to E1 plus E2. Understand? It equal to E1 plus E2. So using the formula, we can use KQ1 over R1 square plus KQ2 over R2 square. So okay, so electric field is not 0 because both of them are going to the right. So they're in the same direction. Unless let's say E1 is going to the left, E2 is going to the right, then they cancel each other. Then there's a possibility the total electric field is equal to 0. But this time, because E1 and E2 in the same direction, they cannot cancel each other, but they add up each other. So is the total electric field at point O cannot be 0. Understand? That's one thing. Now let's talk about potential. Okay. Now let's talk about potential. I want to make a divider. Okay. Talking about potential at point O. Okay. What's the total potential at point O? Excuse me. Total electric potential at point O is there is no direction. Potential is a scalar quantity. It has no direction. And vector is a vector has direction. Okay, it has direction. So you need to treat it as a vector. Yeah, but scalar quantity has no direction. No direction. So there's we don't say potential going to the right, potential going to the left. No, there's no potential. So how do we find the total potential, total electric potential at point O? We just put V1 plus V2. V1 plus V2, understand? V1 plus V2. So for this one, okay. Okay, this potential, okay, so we substitute this potential with the formula. Let's say I put the formula potential. Remember the potential. Okay, talking about potential, when we want to find the total potential, we just total up, just add up. Just add up. There's no direction, no vector. Just add up. So it's KQOR. So KQOR. So if potential provided by charge 1, we can say is KQ1 over R1 plus KQ2 over R2. Understand? Okay. So and another thing is for potential, the charge must have negative sign. Must have sign on the charge. For potential scalar quantity, the charge must have negative sign. So you can see this potential Q1 is a positive charge, Q2 is a negative charge. Q1 is a positive charge, Q2 is a negative charge. So and then they have I can say they have the same charge. They have the same charge, equal amount of charge. Actually, this positive Q and negative Q, they are equal charge, but just opposite sign. Understand? They are just different sign. The different sign, but they are same charge, QQ. So same charge, QQ. So I can say I can put it like this: K positive Q, and then this one is R. And then the distance also, because it's midway, O is midway, so the R is the same, you know. The R, I can say this one, this is R, this one is also R, equal distance. Okay, equal charge, equal distance. You see that? Equal charge, equal distance. So I can put it like this K and this negative Q. Okay, negative Q. For potential scalar quantity, this one, the charge for scalar quantity, the charge must have negative sign. If it is a negative charge, understand? Must have negative sign. So when we put a negative sign there, you see that? So you see, they cancel each other. This is a positive KQ over R is negative KQ over R, so it becomes like no, KQ over R, negative KQ over R, so that they cancel each other. So it becomes 0, potential becomes 0, understand? 0 volt. Compared to this one, talking about the electric field, we want to find the magnitude. Okay, we want to find the magnitude of a vector. Magnitude of a vector. Understand? Magnitude of a vector. The magnitude of vector. The charge for vector, the charge is we don't have, ignore the sign on the charge. Ignore the sign on the charge. So ignore the sign on the charge. So this charge, ignore the negative sign. Understand? The charge ignore. This one we ignore. This one we must have. You see that? For vector, for field, the charge ignore negative sign. But for scalar quantity potential, the charge must have negative sign. So this one, if like you see, Q2 is a negative charge. But when we substitute into here, Q2, we ignore the negative sign. So how do we write it? How do we find the total potential, total electric field at point O? So let's find it. Let's find it. This is K. This is Q. Yeah, Q1 is Q. Over the distance is the same. Yeah, distance is the same. R because it's at the midway. Okay, this is R square, and then this one is plus. This one Q2 is a negative charge. I know, but for vector quantity, the charge you ignore the negative sign, so it become a positive Q. Understand? Positive Q. So it become what? It become 2. It become 2 KQ over R square. So it's not 0. You see that? It's not 0. It's not 0. For electric field, it's not 0. For electric field, it's not 0. But for potential is 0. So the answer is the electric field is not 0. Okay, the electric field is not 0, but potential is 0. I'm correct lah. Total electric field is not 0. It's 2 KQ over R square, but potential is 0. Potential is 0. Because this one, the charge ignore negative sign. This one, charge must have negative sign. That's the difference. Okay, so I hope you understand. Okay, bye.